Okay. So this is what I showed. Okay, people seem to be happy, which is nice. So more energy going from mode to mode, this is mode to mode, m to m. So p to k prime, it is dot product of the receiver and giver mode and dot product of wave number, receiver wave number with mediator. Now there is a catch. In fact, the catch is in fact critical catch, critical problem. Is this solution unique? Okay. So the question is the solution which I wrote, the 6 solutions, there are, well, one solution with 6 components, is it unique solution? So there are 6 linear equations, so we can write them as a matrix equation. So we have this matrix, so unknowns are in this column and known are in the right side column. So unknowns will be S k prime p q, S k prime q p. I will not write all of them, but I just want to p k prime q, like this, right? The 6 of them. So 3 C2. The right hand side are S k prime p comma q, S p k prime q, S q k prime p, and 3 zeros. This was there in the earlier. Now the first 2 entries will be 1 1, right? This plus this gives you that, and remaining are zeros. So you fill up this matrix. There are entries of 1 and minus 1 only. Okay. Now it turns out you take the determinant of this matrix is 0. It's a tragedy, that we did get a solution, but it looks like it's not a unique solution. So we will do some more work. So in that paper we gave some arguments that even though it is not a unique solution, we can make a meaningful answers giving the solution. Okay, but I will not follow that path. That path did evoke a lot of controversy, and that was one reason why our formalism did not pick up so much. So now I have constructed a new argument why this is a good formula. This is unique formula, but you need some more condition. From the 6 equations I cannot prove that this is a unique solution, but I need to put some more constraints, and they come from symmetry arguments. So for a physicist, I think you will be happy that these arguments put in more constraints, and that will convince you that this is a good formula. Okay. So I must go back a bit. So 6 equations I had put one physical argument along with it. What is the argument I gave? That the grad to the quantity to the left of grad, u dot grad theta theta, so that quantity is a edge vector, is like a train carrying this two. So that is also a physical argument. So that physical argument is in addition to the algebra. But now let us do some more algebra and try to show that this indeed is a unique solution, is a good solution. Okay. So let us try to use tensor analysis, and I will try to state some properties of SUU k prime PQ. Now of course I will use some of the properties of the equation. So this is like a physics arguments or argument by physicists. Mathematicians won't be happy, but I am not going to make them happy. I just want physical arguments. So what should be the property? What should be properties of this object? So energy going from P to K prime with Q is a mediator. First thing, it should be real. Energy transfer must be real. No, I don't want it to be complex. Second, it should be proportional to K prime. It should be linear function of UK prime, UP, UQ. Why? Because that comes from the first formula, Craiglang formula. All 3 of them appear and appear only once. It comes from the structure of the Navier-Stokes equation. Remember, so we had u dot grad u and u, and each of the u's are coming here as 3 numbers, 3 wave Fourier modes. So all of them appear only once. So it is a linear function of this, and all of them must appear once. Okay, these 3 must appear. So I don't have u squared uk squared, so all of them appear once and is not quadratic or cubic. By the way, this structure of Navier-Stokes, had Navier-Stokes been like this, then it will have 4 terms, okay. But our Navier-Stokes has this, and it has 3 of them and appearing ones. Because of grad, it is only linear function of k prime, okay. So because of incompressibility, grad comes here and we get linear function of k prime, that comes from the energy equation. And one more condition, that so we have a negative pair, no, the complex conjugate pair. So energy going from minus p to minus k prime is same as energy going from p to k prime. This by again symmetric argument, this k minus this is called parity argument, no, parity. So k going to minus k. Now with these 4 assumptions I can show that this indeed is a solution. Now I am putting additional conditions, okay. So let us put them now. These arguments are again used for more complicated hydrodynamics, like MHD we can apply similar arguments, but I will not do them for MHD when I do it, but this, please see this carefully. Now if this is the case, then I have to construct a general scalar quantity. This is a real number, no, and I have how many things, up, uq, uk prime and k. So I have to construct a scalar. By 4 vectors, how can you construct a scalar? So dot product of pairs, right? You just take pairs and dot product, and either take a real part or imaginary part. Okay, so everybody is happy with this. I mean, this in fact is done. It's not first time I am doing it. This is standard practice to construct quantities using tensor analysis, and the C's are real numbers. So these are 6 possibilities. Now among them, some of them will become 0. So these 3 are automatically 0. Why it is 0? Because of the 4th condition. So let us say if the first term is non-zero, then what will I get? For the negative part, SUU minus k prime minus p minus q will give you the first term. I will just look at the first term only. You can do for the all of them, and you will find there is a negative, there is a problem. So it becomes C1 real minus k1 prime, right? This is minus u of minus q will be star, u star of q minus p, u star of p dot with u star of k prime. Now what is this? Is it related to the first object? So this object inside this complex number is complex conjugate of this, yes. So real part of a complex conjugate is same thing, okay. So this one is exactly same as this one, but you see because of this condition I got a minus sign. So I can't have minus a equal to a unless a is 0. So this implies that these 3 are 0. So the 4th condition was useful, and so this came after bit of algebra. So this condition makes all the real part go to 0. So it must be imaginary. So I got 3 of them. So this is gone. Now what do I with C4, C5, C6? One of them is 0. Which one is 0? Last one is gone. K dot uk is 0, incompressible condition. So we left with 2 of them, C4 and C5. Now this must satisfy those 6 equations. Now I will leave it for you to work out. Just substitute this in those 6 equations. In fact, first equation and 4th equation. Okay. If you substitute in first and 4th equation, you will find that C5 is 0 and C4 is minus 1. This follows, I mean this is algebra. So that means I have derived from this tensor analysis the C4 is minus 1, it is this one. So this is how I said, well, using tensor analysis for phases we can show that this indeed is a formula for energy going from p to k prime with Q as a helper. Okay. So, we had a difficulty that this is not a unique solution, what to do with it, but now we show by additional arguments that indeed it is a solution. But we need to put some more conditions, and of course, I think the physical argument is quite nice, that this guy advects the wave, and I think it's I like it most. So, it is a physical argument. Okay, so with this mode to mode transfer, we can do many useful things.
First assumption was that it should be real.
Yes.
So, since we are taking imaginary part of it,
So, imaginary part of complex number is a real number, no? Right? So, it is a real number in imaginary number. Okay, no problem. Okay, so now we will do something. Okay, now I do want to show one more important point. Now, many times we use condition k equal to p plus q. If that is the case, then we can rewrite this formula. It is useful to have various versions of the formula. So, I just put k prime is minus q, k prime is minus k. So, this becomes, so this minus k prime becomes k, and this u k prime becomes u star k. So, you have to remember both the formulas, no? But they are, once you remember, you know this, you can easily convert this. So, many times we use this second one. Okay. So, if this is how your triad is represented, then use that, otherwise we use this. Okay. So, Cray-Haring, now I am just going to show you in, so Cray-Haring we did in the class. So, how does the formula look like? So, Cray-Haring was very specific, k prime plus p plus q, k prime p q, and there is 0, and that formed a triangle, and we had, it is very useful formula. We did derive our modes, but now we can also write down formula for energy transfer. So, it is, you just follow the same technique. So, I will just sketch it here. So, k prime dot u q becomes, k prime is along E3 direction. Okay, please remember this. Huh? Now, u q will be along u1 and u2, but u2 is perpendicular to E3 the plane. So, u2 does not contribute at all. Okay, so u2 does not contribute at all in this. So, they form a plane, and my u1 was in the plane, but u2 was perpendicular to the plane. Everybody remembers this? Huh? So, this was E1 and E2 was into the plane. So, u2 will not give anything from the dot product, in fact 0. Now, this dot product has two parts. One is E1 dot E1, because E1 and E1 in the same plane, and E2 dot E2, but the E1 dot E2 is 0, because they are perpendicular to each other. So, this is what we get. Now, from the table which I showed you before, and these are two terms. Okay. Now, this is coming from the dot products, so you just take from the table, and so the sin beta cos gamma minus sin beta, and this is very useful. Okay. I mean, you can do it for your projects, and we can use this blindly. The dot products become complicated sometimes, but you can do this. I did field theory with this. It was very useful to do field theory with this. So, the formulas become compact. It's chapter 10 of this book. Now, in 2D what happens? 2D some terms go away, no? So, 2D E2 this is 0. So, 2D this term gone. So, 2D is much simpler, it's just that. The first term exists, U2 does not exist. Okay. So, I have derived mode to mode now in Cray-Haring as well. So, this for completeness. Okay. So, we stop here.